Did you get a chance to do 9 and 10 or not yet? All right. 9, 9, and 10. A lot of warm-ups today. Thinking them out right now. You might even just start by writing it that way, and right away it's what you call. But they do it wrong. They do it respectfully. Really? Mer? That was great. Mer. What'd you get for 9? 9 is pretty easy to get done. What'd you get? Talk to me.
I don't know.
Why? It's easy. Corey, what'd you get? 9. What? Corey? Writing it down. It was my favorite for a couple days, but now it's gone. Yeah, man.
0.
What's that? That's what's 1 divided by 8?
Just kidding.
Yes. Why couldn't it be?
I don't know.
All right. Is infinity minus infinity indeterminate or determinate? Indeterminate. Do I take derivatives on the difference or do I need to make it a quotient first? You must make it a quotient. Do not take a derivative in this form. You cannot. So instead, how do you make it a quotient or a ratio? And that is by getting a common denominator. Is you get the equivalent equation sine of x minus 1 or expression over cosine of x. Cool. You will find that that's still indeterminate. So now go through L'Hopital work. Sine of x minus 1 goes to 0. Cosine goes to 0. So L'Hopital is in effect. And therefore the new limit is equivalent to cosine of x over negative sine of x, which is 0 over negative 1, and therefore 0. And then 12, it says same differential equation, but I don't know what that differential equation is. Anybody have their book out? I got it. Don't you worry. Just sit there. I'll take care of it. No problem. 12, the differential equation is y dx minus dy equals 0. Use that differential equation, but I want you to find a particular solution in function form through 2 negative 1. Go. Esther, now let's start. Thanks, pal. Does she have another paper? Is there one of Esther's in there? See Esther. I don't know if he's slow or methodical. What? I thought you were getting it for me. No, okay. Should we even go through the pretense of you having to take this here? All right, you doing this? This one is like.
Wait, actually, I might have.
All right.
I mean, it should, but I'm going to get it.
Are you ready? Carrie, you ready?
I think I did.
Test. You ready? All right. Here we go. To separate these, you probably want stuff on splitting sides. You can do a little crossy cross. So you get y over, nope, that's terrible. You never have dy's. You never put differentials in the denominator. That's bad. So dx is dy over y. Yay? Integrate. What's the antiderivative of dx? X plus c, and the antiderivative of 1 over y. X log of y of absolute value of y plus, oops, not plus c on both sides, dumbed up. All right, so now we're going to find the initial condition, or use the initial condition. X is 2 when y is -1. You can see if you don't have the absolute value, then you're going to break math by taking the log of negative. So c is -2. Do you agree? X minus 2 is the natural log of the absolute value of y. Now you need to solve for y. What do? E it, or exponentiate it. E to the x minus 2. The y is still an absolute value. Exponentiating does not remove that absolute value. It's still there. Y is plus or minus e to the x minus 2, which would use or satisfy the initial condition. When x is 2, y is -1. It must be the case that y is negative e to the x minus 2, based on the initial condition. All right. The notes. Let's go to the notes. The derivative of an inverse. You have tons of how to take a derivative knowledge. You have product rule, power rule, quotient rule, this and that. There are still some derivatives you still do not know how to take. This is one of them, derivative of an inverse. I'll start with a little review of pre-calculus. Would you complete that table? Do it in 10 seconds. Go.
This is from like the function.
What?
This is the function.
Yeah, why do you have it?
I don't know. I treat it that.
You don't have notes? That's weird. All right, are you done? That's 10 seconds for sure. Okay, boom. Give me the row of x's. X's.
0.
No, wrong already. Go. Try again. 7, 11, 4, 2. And the y's are f inverses? 0, 2, 3, 5. The inverse is a switch of x and y. When you find an inverse, swap the x's for the y's. That's what an inverse is. Okay? It does not mean reciprocal. So if you put 1 over 7, that's ridiculous. Get out an eraser and erase it. That's not true. Reciprocal is not inverse. That's just not at all true. Okay? Would you recall finding the inverse? What is the step to finding the inverse? What do? You switch x and y. So this is x, and the minute you switch, this is now f inverse. The minute you switch, you're talking the inverse now. If you wanted the inverse explicitly, then you would still have to solve for f inverse. F inverse is x minus 2. You with me? Now it says prove their inverses. To prove their inverses, if two things are inverses, then they should undo each other. What's x plus 2 minus 2? X. What's x times 2 divided by 2? X. What's e to the x, then the log of that? X. Inverses should undo each other, and you're right back to where you started. Therefore, if these are truly inverses, then if I do f composed on f inverse, or in other words, put the inverse into the function, I get x minus 2 plus 2, or x. Likewise, if I went the other way, if I put the function into the inverse, then that would mean x plus 2 minus 2 is x. Either way, inverses should undo each other, and you're right back to where we started x. Now that's important because that's where the derivative rule comes from, is a chain rule on that. We'll get to that in a minute. Would you please find the inverse of that function implicitly and explicitly. Go. Also, would you throw an arrow at which one's implicit, which one's explicit? Label it. Ready? Cool. Give me the explicit form of the inverse. No, give me the implicit form of the inverse. Kylie, go.
X equals 2e to the inverse plus.
Wonderful. Okay? The minute you switch, you're talking the inverse, and in that case, F inverse is not solved for, it's implied. This is the implicit form. F inverse is implied within that. Explicit means not profane like explicit lyrics, but clearly stated. Okay? So what shall I do to solve for F inverse? Subtract 3, divide by 2, take the log. And so F inverse solve for, or explicitly stated, is log of the quantity x minus 3 over 2. You follow?
Yes.
All right. You also need to be able to do that to do calculus on it. Now let's talk about there we go. Nope, that's what the heck.
That's it.
Is that there?
Yep.
Okay. Would you sketch the graph in its inverse? So what is y equals x times x plus 2 quantity squares basic shape? Cube. All right. What are the cube zeros?
-2, 0.
-2 and 0. Is it a positive cube or a negative cube? Positive. And the 0 at -2, is it pass through that 0 or bounce off of it? Bounce off. And at 0, does it pass through or bounce off? Pass through. There is the original function y. Now let's talk the inverse. I don't want to actually find the equation for the inverse. That would be a mess solving it, unless it was implied, I guess. But let's just do this visually. We say the whole idea of inverse is to switch x and y. So instead of an x-intercept at -2, we're going to have a y-intercept at -2 when we do the inverse. The other 0 will be shared at 0. Switching 0, 0 still is 0, 0. All right? Now, let's talk then the shape of this. This is as x goes to -infinity, y goes to -infinity, eh? Our graph will do the exact same switch then. When I switch these, y will still go to -infinity and x. So this part would be exactly the same as that, yeah? Here, I'm going to then bounce off this. Don't you agree it bounces off an x of -2? So my inverse will bounce off the y of -2 and then go till it hits that other root and pass through. Where's the symmetry for a function in its inverse? Okay, now remember the whole idea of an inverse is to switch x and y. Oops, sorry, switch x and y. If I switch these, then don't they just reflect right across that mirror? X's and y's switching means it just, if you fold it right across that line, it would fall into itself. You follow? So when you write yourself a note, symmetry about y equals x. All right. Now let's go here. These are not necessary. There we go. Bring those back later. Okay. Now's the calculus. Let's talk about the calculus. Would you graph the square root function, please? 0, 0, 1, 1, 4, 2, 9, 3. Graph it well. All right. Now then, would you sketch the tangent line at x equal 9? Sketch the tangent line at x equal 9. Feels like it would be kind of flattish. Oops. should be a little flatter. Darn. Okay. All right, something like that, yay? All right, cool. Pretty flat slope there because the curve's not growing very fast. The derivative is small and therefore a flat slope. All right, now the idea is this. Would you now graph the inverse to the square root function? So switching x's and y's. So 0, 0 stays 0, 0. 1, 1 stays 1, 1. And then 4, 2 will become what on the inverse? 2, 4. And 9, 3 becomes 9. All righty. Now, the idea of the slope of the inverse. The question of the day is what happens when you take the derivative of an inverse function, okay? Now, first and foremost, we're going to have a little switchy switch. If I want to relate these two, then an x of 9 on the original would correspond with a y of 9 on the inverse. Okay, x of 9 gets switched to y. So the inverse will involve looking at the y on the original rather than the x. Next thing is the slope. Well, let's talk the slope. Surely this slope, you could estimate it as maybe actually you could probably find it exactly. What is the slope of the tangent at 9? Talk to me. You guys are ticking me off. What's the slope at 9? It is 1 over. You guys, 1/6. Yeah. All right. So the slope is 1/6 then. Now surely this slope is not 1/6. So the question is, well, what is the slope? It's 6. Yeah, it's the x's and y's are getting switched. So instead of changing y over changing x, it's actually behaving the exact opposite. So this slope is 6 over 1, not 1 over 6. The idea then, it seems like the derivative of the inverse is the reciprocal of the normal slope, but at the y of the original, not the x. Okay. The slope of 1/6 at x equals 9 is like the inverse is 6 over 1 at y equals 9. You with me? All right, now that's pretty kooky, so let's clean this up instead. Let's go with this instead of visually analytically. We just said that the function and the inverse should undo each other so that when you compose one on the other, you should get x. That's an accepted fact of inverses, right? Now from that, we can get a derivative rule for inverses. So let's start with that fact. If it's accepted that this is true, let's take the derivative of both sides and see what happens in terms of derivatives on this big fact. All right? Now the left side, that's a bit of a mess. It requires good calculus skill. How do you take the derivative of the left? Chain rule. The derivative of the left is the derivative of the outside function with the inside the same. So the derivative of the outside with the inside the same is f prime at f inverse times the derivative of the inverse, which is f inverse prime, right, equals the derivative of the right-hand side, which is 1. Therefore, if I want a rule for the derivative of the inverse, then I want to isolate that guy. That's the question is, how do you find the derivative of the inverse? Well, that's right there. Derivative of the inverse is equal to 1 over, or the reciprocal of the normal derivative at the inverse point, not the normal curve. All right, that is the idea for the derivative of an inverse. It's 1 over f inverse prime is 1 over the normal derivative at the inverse point. Now, by far the harder part for students is the inside. The derivative is not hard for anybody. Okay, this takes some getting used to, but once you get used to it, you'll find these are pretty straightforward. So this is maybe what a question might look like. What is g inverse's derivative at 2, given that the original function g is x cubed plus x? Okay, so this is also what my work should look like. G inverse prime at 2 should be 1 over g prime at g inverse at 2. Using the formula or theorem we just created. You with me so far? All right. Now to do this, I need g inverse at 2. I can't do g prime at jack anything until I know what the inside of that thing is. So now finding g inverse at 2. What is g inverse at 2 equal to? Now, how do I find that? That's an x on the original. X is 2 on the original. If x is 2, sorry, on the inverse. If x is 2 on the inverse, then doesn't that mean y is 2 on the original? You follow? Okay, so if I go to the original, then that 2 actually would be there. And I say, all right, so what is the x that made it? Now, the good news is you will not have to solve cubics for these problems. They will be x and check. What's that? What x would make that true? 1. Okay. All right. So that said then, I know that g inverse at 2 is 1. So going back to the problem, I gathered what I needed. G inverse prime is 1 over g prime at, and we said g prime at 2 is 1. All right. Now I'm ready to do the rest of it. What is g prime? 3x squared plus 1. I'm going to write that way and say I'm going to put a 1 in, but first I'm going to show you the derivative. Before I put 1 in, then I'm going to put 1 in, and so my answer is 1/4. All right? Try this one. Suppose you could do a bunch of pre-calculus to solve that, or algebra to solve that, but you might be able to just look at what x makes that true. 0. And what's the derivative of e to the 2x plus 1? 2e to the 2x drops out. And so your final answer is 1 over 2e to the 0, or 1/2. Okay? Okay. Let's try a little funkier one. I don't remember why I have this one. I know this trig needs to be found. Try this one on your own, please. Or if you're not amigo. And you don't have to keep writing all that. When x is this, y is that stuff. If that helps you, great. But if you can just mentally figure out what's the inverse of sine at root 3 over 2, cool. Obviously, sine is root 3 over 2 at lots of values, but we're talking the inverse of sine, so restricted to first and fourth quadrants. What's inverse sine of root 3 over 2? Pi over 6 or pi over 3? Pi over 3. Okay? So the derivative of this is cosine of pi over 3, and what is the cosine of pi over 3? 1/2, so it's 1 over 1/2 or 2. I can't remember why I put this on there, but I trust that I have a point to it. Do I have a point to that? Try it anyway, just do it. Stop back talking to me. What did you get? 1. I think maybe my intention of this was to make you appreciate that the ones in the book and on the AP test are pretty soft. This can be pretty gross. If you have a cube that isn't, this cube, whether you know it or not, is constantly growing. If you have a cube that has extrema, then when you invert it, it'll look more like that. Now the problem then is at 2, you could have, or negative 2 maybe, you could actually have 1, 2, 3 different possible slopes if they really wanted to mess with you. That you probably will not see unless you become a math major. All right, then let's try some AP practice. This is more of an AP vein. Would you try these two and see if you're on your game graphically and numerically? And then we're done. We did analytically. Now this is graphically and numerically, a table. When you hear numerically, think table. Ready? Bit of a humdinger. I should give you another minute. Sorry, I don't want to rush you. Take little steps of logic.
Wait, are this box the same as this?
No, that equation is, that table is for something else. Separate problem. Okay, let me know when you've got both of those done. Make sure you don't have your phone out, so I'll take you and slap you with it. Okay, so what'd you say graphically? 1/7. 1/2 or 1/7? I actually haven't done this yet. So would you agree that this is the big idea of derivative of inverse? Okay, so I need to establish what is G inverse at 2. Well, that is when x equals 2 is on the inverse. That's 2 is going into the inverse for x, which would imply or match y equal 2 on the original. When y equals 2 is on the original, that's at an x of 1. Now I have to actually find the original slope at 1. What is the original slope at 1? Isn't it up 4 over 2? So isn't the slope 2? And so the slope at 1 is 2. The answer is 1/2. How'd you do? Okay. This guy, G inverse prime at 2 is 1 over G prime at G inverse at 2. G inverse at 2, does that mean I say, oh, here's 2 and boom, it's 1, or the other way around? Yeah, I'm actually looking for where when the y is 2, what's the x? Well, when the y is 2, what the x is 1. And then what is G prime at 1? 7. Oh, you were giving me the answer to the other one. Okay, I got you. All right, do anything? Okay. These are, I've only seen 2 of these on a free response in 18 years, but it's always multiple choice. It's at least one multiple choice. Okay. Questions on set 91. 2, 1, 10, 4, good buddy.
14,
14, 19, 20. Okie doke. Excuse me. All right. Let me make sure I'm not missing on that. Here we go. Okay. 2 is not a place. Okie doke. Just B, 2B. All right. So for part A, what did you have for x at 0 and x at 2? X at 0 was 9, and x at 2 was, oops, nope. Sorry, I was looking at the wrong set. X at, oh shoot, never mind, I'm looking at the wrong problem. Let me start over. Okay. All right. Particle is at time 2, x is 9. What's the position at time 0? Do I understand the question correctly? Okay, so you say that the big idea is that the antiderivative velocity is position. And if I use the fundamental theorem, this would be logical to tie 0 and 2 together, right? So this would be x at 2 minus x at 0 if you go way back to the most basic fundamental theorem. You could therefore solve for x initial by moving it here and this back, which is to say x initial is final position take back the change that happens in the time frame. That's,
Mr.
yes.
Yeah. I think
Yeah.
it's at exit 6 is what you're trying to.
Oh, 6, not, yes, sorry. 6. Up on it. Thank you for stopping me. What is the position at time 6? Thank you. So they give you exit 2 is 9, but exit 6 is the question. Shoot. Thank you. All right, so, sorry. Change that a little to 2 to 6 would be is exit 6 minus exit 2, yeah? Therefore, exit 6 is exit 2 plus the change going forward. Okay, sorry about that. All right, exit 2 they gave you is 9. And then let's talk the change. I don't know if you have to show all this work, but the idea from 2 to 6 is to say 2 to 4 is this, and 4 to 6 is that. There's the additivity idea of integrals. This is what you're to use. This is very nice work if you show that, but if you just went straight to 9 plus the integral from 2 to 4 is -5, and the integral from 4 to 6 is 10, that is where they're getting their answer 14. I assume that's the answer. You with me?
Yeah.
Okay. 1, is 1 still a question? Yeah? Okay? All right, so you're talking a cone of radius 4 centimeters is the foundational idea, and you're describing a cylinder within. Oops, this is a side 6. And you're inscribing a cylinder within. Now, surely there are many cylinders you could make within. You could do a short, squat one or a tall, thin one. You're going to try and maximize the biggest cylinder you can get in there eventually. But first, they walk you through it a little bit. Express the volume of the cylinder in terms of R. Now, if the volume of a cylinder is pi r squared h, and you're going to do this in terms of R, then you need some kind of other RH relationship. That's where they are giving you this cross section. If you were to cross section and slice it like this, then you would get this kind of green similar triangle thing like this, right? Where this here, that represents the radius of the cylinder. This is all the way to the edge, which is 4. This here is the height of the cylinder. This then would be 6, take away that height, so this part is 6 minus h. You follow? By similar triangles, then you can set up a proportion. R is to 4 as h, nope, 6 minus h is to 6. You follow? All right. Therefore, what do we want to solve this for? R or h? They say in terms of R. Okay. So if I want this in terms of R, then I need to put in for h, right? So I need to solve this for h. Because of that, I think I'll do this in a cross multiply kind of way. 6r equals 4 times 6 minus h. 3 halves r equals 6 minus h. Geez, this sucks. Subtract 3 halves r minus 6 equals negative h. So h is 6 minus 3 halves r. I don't like that at all. I'm gonna make sure I did that right before I move on, because I don't want to plow ahead when I made a mistake early. If you're gonna make a mistake, make it later in the problem, not earlier. So, let's see. Okay, it feels like that's okay. All right, so if that goes in there, then volume is pi r squared times 6 minus 3 halves r. After that, it's up to you if you distribute or use the product rule. What do you want to do, distribute or use the product rule? All right, if you distribute, then you get 6 pi r squared minus 3 halves pi r cubed. I think that's a good call. That's a little easier. All right. Now then, A is done. B, find the radius and height to maximize the volume. That means find where, now does this mean differentiate with respect to time, or find d prime with respect to r? With respect to r. So if I find d dr, I get 12 pi r, dr if you like, minus 9 halves pi r squared. I'm going to find where this is 0 or undefined. If I take out a pi and an r, then I'd have 12 minus 9 halves r equals 0. This could be r equals 0, which is ridiculous, that can't happen, or 12 minus 9 halves r equals 0, which is to say 12 equals 9 halves r, or r is 12 times 2/9. Or 16/3.
Wait, 3 goes into 12 4 times, not 8 times.
You think so? 3 goes into 12. What? Oh, 4 times? So 8/3, yeah? Thank you. That's good critical thinking, Kylie. You had a kid. All right. So if r is 8/3, then height is 6 minus 3 halves of 8/3, which means the height is 2. And
Good morning, Devin Jaguar.
then the max volume equals
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so you're rolling there.
All
That's
boys,
part
8th
B.
through 11th grade, interested in playing
C is
basketball or
find
soccer,
the
next winter
values.
need to attend an information meeting with the coaching staff on
10, question on 10.
Opening day for Jack's baseball is coming Saturday, March 9th. Varsity plays at 11 a.m. and JV at 1 p.m. Both games will be at home, so come cheer on your dad.
Simon thinking to join our June 2020 trip to Italy, France, and Spain. At current pricing, guaranteed through Friday, March 8th. Check out the information on Mr. Abel's website or reach out to him in person. Join the 24 other Jacks abroad who have already booked their spots on this great venture.
Okay,
Senior high students.
so to find the average velocity, I'll need both the velocity function and how long it's in the air. So if the acceleration due to gravity is negative 32,
Senior high
because
students
it's
who are
feet,
interested in helping with the junior high drama production this year, please stop by the stage crew meeting this afternoon right after school in drama.
because it's dropped, the velocity is 0 at time 0. The velocity is negative 32t. Yeah? Alright, now I need to find when it's in the air. That means find when it hits the ground. So I need to also
Come join
find
Cheyenne at the Classy Masquerade
the height.
on Saturday, March 9th at 7 o'clock. Black tie
It's negative 16t squared plus a constant. The height is 576 at time 0. And the height is negative 16t squared plus 576, right? This equals 0 at the square root of 576 sixteenths, which is the square root of 36, which is 6
all
sevenths.
junior high students interested in working on the
So
stage
now the average velocity
make up for the junior high play.
is 1 over 6 minus 0.
March 7th. The meeting will only be about about 15 minutes long, so no
I guess I could do this.
in creating the physical world and creatures from Lewis Carroll's poem, The
I
Jabberwocky.
could do this.
Jabberwocky,
But could I also find average velocity by doing height at 6 minus height at 0?
That's what I tried to do.
Yeah, that's smart.
Held at the YMCA channel in Estes Park in July. Entering
So
11
that's the average velocity. That's good.
RYLA is one of the finest leadership programs available to high school.
All right. 4. Anybody 4?
The Master Service is proud to recognize Apparatio for its excellence in concept. Intuitive and curious, Drew craves intellectual challenge and consistently shows his interest in understanding concepts more than simply mimicking processes. Drew is talented by learning and committed to mastering the most difficult concepts. I often joke that when he records the name on his test, he should write the key Apparatio, since his answers are likely 100% correct. Congratulations, Drew. Drew was elevated to second candidate.
Addie Bob Hoffman has been a hard-working student all year in algebra.
Equals 0, A and B. Okay.
She always works hard and has a positive attitude in class. She even stepped in recently to help explain a lesson when substitute teachers didn't have a great idea of what was going on. Outstanding job, Addie. Addie was nominated by Mr.
Cosine of 0
Will
is
Jackman is a junior high boy
pi
scholar.
is
Will
5
always
over
has a
2,
great attitude for learning and walks into class every
3
day
pi over
eager
2,
to
5
work.
pi over
He has excelled on every test and done very well on all other assignments as well. However, the reason Will has earned this award is his desire to learn and ask questions that push critical thinking on the topics we cover. He always wants to know more and find out about everything related to the material. His interest in what can be done with mathematics is outstanding. Great job, Will. Will is nominated by Mrs. Slaughter.
Kendall Gromko is the Female High School Scholar of the Month for the Math Department. Kendall is acing Calculus BC this year, and that's not easy. Because Kendall is quiet, she flies under the radar, but she is one of the top students in the class. This young student with a bright smile.
Uh-oh, they put it up. That's funny. Distance.
That's the younger student who wants to say that. Kendall is nominated by Mr.
On. All right, let's do like what?
Did you put 14 and 20?
Mr. You should have nominated Jasper.
Who? Jasper? Yeah. Come on, Mr.
Jasper, like you should nominate both. That's it.
Feels like the nomination should go to somebody who does all the problems.
No, 20, not 19.
Or any.
What? Not or any of the problems.
One.
This, these?
Can you also do
There's a slight issue with
Jeez Louise.
I'm just trying to do my. Okay, this
They just come in 7th hour.
I can't. I have to go to chemistry.
Hapu.
I have to do first.
Hapu.
Yes, I got. I tried. This is the whole class I tried.
I cannot put in my recommendation. It's the only class you tried.
How?